Good morning, everybody. Thank you for coming all the way. I know some of you guys came from very far away, places like China, Korea, Japan, Israel, all those nice places. Thank you for taking the time to be here and making the time for us. We really appreciate it. What I would like to do today is talk a little bit about where we are and where we are going. Give you the big picture, the way I see it from my perspective as being an entrepreneur. So first of all, the number of people that we have here compared to last year when we spoke, more than doubled. Now, I think it's very significant. It showed the interest that we have. But one more significant number, at least for me, is the number of actual production deployment that we have. The number that we are tracking is about 50, and it's up almost sixfold from 8 last year. This is very significant. It shows that you guys trust the code that we have. It shows that you guys believe that you can use Scylla for database, which is usually the most critical component of the application. I think it shows the maturity of where we are. This number is not really accurate because we are open source. The nature of open source is that we don't know exactly what's going on. We know when problems arise, and we find out as we go that there are actually more and more people that are using Scylla. What you can see here on the right side, you can see a meetup that we have done. We are doing all kind of outbound type of marketing, like a webinar. It's very important for you to help you to promote Scylla. We see it as a journey. We need your support, and we believe this can be a career-changing event for everybody, just like we have done in the past with the KVM. So let's talk a little bit about databases in general, databases evolution from the perspective of non-SQL and specifically about Scylla. So when the world started, the world of computing, I mean, in the 70s, 80s, you can see from my right here that I've been around for a long time. I've seen it. We started from basically databases that were relational databases, SQL databases, and the whole idea about scaling was scale up. If you needed more performance, you buy more expensive, usually mainframe. You buy more memory, you add more storage, but it's usually scale up. This is very expensive when it comes to scaling, and it doesn't hold for all kind of applications that came about in the late 90s, and we needed a different approach. And this is where non-SQL came about. The name is really bad, but the main promise of non-SQL were based on two main forces, two main changes in the industry. One was the reliance on COTS, commercial off-the-shelf hardware servers. Those are the cheap one I use, usually based on x86 architecture. And the second one was open source software. These trends of OSS and COTS made it really cost-effective to build very high-scale solutions. Companies like Amazon, Google, Facebook have built their success based on the new architecture. In fact, some of the new companies that we see, like Airbnb, like Uber, Lyft, couldn't exist if it was not for this change that we have experienced. This was an amazing success. Not only we had a success in the databases, we have also success in the ecosystem that was built around those databases, new databases. You can see on the right side the amazing explosion of tools, analytical tools, and all kind of other frameworks that were created on top of the non-SQL infrastructure that we have. It was a very successful value proposition, I would say even too successful, in the sense that it was written for the most part, I'm talking about the databases, in Java. We could get away because it was so much better, at least economically, than the alternative. But there were issues. The issues were it is not that stable. There are performance issues, both on latency and consistency. There are issues with the stability. The code is not that stable, and what we have seen that people are actually looking at those applications and changing them to compensate for the issues that we have in the databases. From software engineering perspective, this is the wrong way to do it. A better way is to fix the problem that we are having with the databases themselves. The only good news that I can see here is that the cloud actually helped prolong the non-SQL as we know it based on the old implementation of mainly Java, because you can throw more and more resources at the problem, and in many cases it will solve the problem. But in most of the cases, the problem is not solved. You're spending more money, and it's far less stable. So there needs to be a solution. There needs to be another solution, another approach. And I think this is where Scylla comes in, and this is why Scylla is so important. You can see that the architecture is different than what it used to be. I have here the architecture of C star, but it's not only C star. Glober here told me about a year ago, look at the type of people that we have that have built this solution. So we know we have people who understand operating system, hypervisors, they understand databases, and they understand the operational part of running some mission-critical application like databases. We better understand the environment. Now that we are pretty much 20 years, almost 20 years into this trend in the industry, we have the advantage, the unfair advantage of being latecomers in the sense we better understand the environment of whatever is running on top of us. We better understand what's running underneath us. We understand the hardware, especially on memory, especially on networking. This can help build the next generation as we see it in a far better way. The solution that we have is not the first generation. You can look at Scylla as basically the grandson of DynamoDB. It was DynamoDB, then it was Cassandra, and now we have Scylla. We are using a lot of the experience that we have learned directly and indirectly from this implementation. This is exactly what we did when we came up with our KVM implementation. The solution can do scale up like the original one, and it can do the scale out and up, sorry. But our vision is much bigger than that. We are not looking at replacing Cassandra. We started from generic C star. To be honest with you, we started with something else, OSV, but this is another lecture. So we started with C star. We are right now focusing on taking the C star engine and moving it into Cassandra. The next step is to take all these good things that we have created and take it to other non-SQL type of databases.